Hello everyone, welcome back to my channel. In the last video, I've shown you how to prepare and measure a BIOS state on a IBM Quantum Computer. And in this video, I would like to extend it to more qubits and prepare and measure the so-called GHZ state. So we'll first do it on 3 qubits and then on 5 qubits. So let's get started and go to the website and log in into the IBM Q experience. And we can go to the circuit composer and let's build a new circuit. We'll change the name to test to GHZ and then save the changes. Okay, so we first need to create a superposition state on the first qubit using this Hadamard gate. And basically after the Hadamard gate, the first qubit state changes from 0 to 0 plus 1 over square root 2. And then we can create entanglement between the first two qubits by this C0 gate, and then create entanglement between the second and the third qubit with the C0 gate. And basically by this, we create entanglement of the 3 qubits, and this is the so-called GHZ state. And if you write in the basis of the 3 qubits, it is 0, 0, 0 plus 1, 1, 1 over square root 2. And then we can do the measurement. We can measure the first qubit, measure the second qubit, measure the third qubit. And this is our circuit. We have 3 qubits, so and that is 2 to the power of 3 possibilities. That is 8 possibilities. However, in this measurement, because this is a GHZ state, it should only consist of 2 possibilities. One is 0, 0, 0 and one is 1, 1, 1, both 50%. Okay, so now we can run the circuit. So the first one, simulator, is simulation using classical computer, which is not very interesting. And this time we'll go to this Vigo quantum computer, and let's say 4,000 runs, and then run the code, and it is sent. And this is the pending result. And then we go to the results to track whether it is finished or not, and then we can click this refresh and wait. Okay, now it is finished, and then we also refresh the completed list. And the most recent one is the job that we handed in to the IBM Q Vigo machine. Okay, and then you will see that there is around 50% 000 and 50% 111, and the first 2 digits, they are the qubits that we didn't use, so it is always 00. But still, you see there are a lot of other possibilities that exist, and this is because there is error in the quantum computer. Okay, so now we have demonstrated the 3 qubit GHZ state. And then what we can do is that we can modify the circuit and then add more entanglement. So we first remove the measurements, and then we create entanglement before the 3rd and 4th and 4th and 5th qubits. And this is the 5 qubit GHZ state, and basically it is 0, 0, 0, 0, 0 plus 1, 1, 1, 1, 1 over square root 2. And then if we measure it, in principle, there are 2 to the power of 5, that is 32 possibilities, but we will only get 2 out of 32 possibilities, that is all 0 or all 1. So we save the changes and we run the code, also on this Vigo machine. Before we move to the result, there is one feature that I forgot to mention in the previous videos, and that on the left hand side, you not only can go to the circuit editor, and this is basically the programming language, or you can go to this visualization. You can choose the state vector or measurement probabilities. And this is basically the classical simulation of the circuit, that you will have 50% all 0 or 50% all 1. Before you run the circuit on a quantum computer, you can go here and check what is the expectation of the outcome. Okay, so now, and you go to the results. So now it is finished, and then we refresh the completed list and the most recent one, and we see that the circuit is indeed what we have drawn before. And this is the measurement that we have 0, 0, 0, 0, 0, and 1, 1, 1, 1, 1. Each of them around half the possibility. All of the others are just errors. So in this video, I've shown you how to prepare a GHZ state using 3 qubits and 5 qubits in IBM Quantum Computer. And so thank you for watching, and I hope to see you next time.